Hi, hello, how the heck are you? I'm Dr. Corinne Deegan, and if you are watching this video, I'm assuming you're here for the solutions to the practice problems I posed earlier this week. This video's questions are for the Physics 1 math review practice problems that I posted, and I already know why you're here, so let's get into the solutions.
So for the first question, I didn't give the answer to this in the actual questions when I posed it because this one was multiple choice. So I asked which of the following arrows is perpendicular to the purple line, and I did say that there could be two answer choices to this. So there are, or I guess I said that there could be more than one. There are two answer choices to this. So the correct answers are going to be B and D. So this is going to come in, I think it's a little bit easier to identify which of these lines is perpendicular once they're drawn already for you. But something we want to keep in mind as we start getting into physics is you're going to be drawing diagrams, especially ones that kind of look like this one that's on an incline. And you'll have to start with, say, you have something that's on an inclined plane, so maybe you have a car on a ramp, and you need to identify a force that's going to be perpendicular to this, and we want to keep in mind that when we're drawing that perpendicular, it's a little bit off, but should be pointing in this direction, whereas the way that I have it pointed in the option C is that it's pointed just straight up along, like if you had a y-axis that was positive and negative, it would be pointing along the positive y, but the positive y would not be perpendicular to the ramp that I have drawn here. So something more so that I feel like is going to come up when you're actually drawing these pictures yourself, but it is going to be important to be able to know and distinguish your perpendicular from your parallel and be able to use and understand those descriptive words if they're just used in problems, because professors and teachers are going to assume that you know what perpendicular and parallel mean, and they'll probably just go ahead and use them without giving any sort of conditions or explaining a lot of things further. Okay, so for this one, we want to isolate the variable k, which is down here in the denominator, so we want to rework this to get that k by itself, which is going to involve some ugly math, so let's get to it. So the first thing I would say, maybe not the easiest thing to do, but it's the first thing that I see to do, and that's to divide both sides by 2 pi. So we'll get those 2 pi's canceling out in front of that square root. So we'll be left with capital T over 2 pi equals the square root of m over k. And then I would go ahead and square both sides to get rid of that square root that's on the right. And when we do this, you can leave it just as that parentheses squared, or you can distribute it. So if we distribute it, we'll get t squared. The 2 is going to become squared to become 4 in that denominator times pi squared. And that'll be all equal to m over k. And then when we get here, I'm going to take this slow also. I'm going to multiply both sides by k to get it out of the denominator. And then, yeah, I should have enough room that I'll do this in 2 parts. So we'll get k times that t squared over 4 pi squared all equals m, and then to get that k by itself we have to multiply by the reciprocal of everything in those parentheses. So it'll be 4 pi squared over t squared, 4 pi squared over t squared. So then basically you can see that 4 pi squared will cancel that one, this t squared will cancel that one, so we'll be left with, and then we can simplify, k equals, I'm going to put the 4 pi squared out front, times m over that t squared. And then that would be your final answer there. Making sure that you're distributing that squared to everything inside those parentheses, making sure you're remembering how to even get rid of that square root with the squared in the first place. Those are all things that you need to be able to keep in mind to solve this. This is one of the more complex equations you can have. Okay, and then last one, we want to find the length of each unknown side of the triangle below, where I gave you the hypotenuse. It's a right triangle. I gave you the hypotenuse and the angle. So there are kind of two perspectives you can take on your right triangle trigonometry from physics. You can deal with or approach it from the unit circle perspective, which the unit circle perspective is always, if this is your unit circle going around, your angle is always going to be defined with respect to the positive x-axis. So 0 is always along the positive x-axis, and then your x component, typically they call that radius r. This would be your x component. This would be your y component. So in this case, you're always going to have your x component be the radius times cosine theta, and you're going to have the y component always be the radius times sine theta. But you'll see in physics a lot of the time, the problems that you can get, you'll have this angle defined not always with respect to this reference line that I'm going to highlight. So in that case, I tend to advocate for using SOHCAHTOA method. So the definition that sine is equal to opposite over hypotenuse. I'm summarizing here. Cosine is the adjacent side over hypotenuse, and these should be absolute value bars. And then the tangent is the absolute value of opposite over adjacent. Oops. So you have that. Otherwise, the shorthand, which I'll pretty much write on any solution that I need to use SOHCAHTOA for, which is a lot in physics, unfortunately, I would just use that abbreviation. So since we have the hypotenuse and the angle, and we want the adjacent side, which is x, and the opposite side, which is y, I'm going to use cosine and sine. So I'm first going to set up that sine of 41 is going to be the opposite over hypotenuse, where the opposite is y, and the hypotenuse is that 9. So we can multiply both sides by 9, and then I'll just simplify 9 times sine of 41 is going to be equal to that vertical component, and then make sure your calculator is in degrees and not radians, because that angle is in degrees. And I'm going to round to 1 sig fig, and I get 5.9. And then I'll set up something similar for the x component. So for the x, that's the adjacent side. I'm going to use cosine 41 equals adjacent, which is x, over the hypotenuse, which is 9. Oops. And then I'll again multiply each side by 9. So we'll get 9 times cosine 41 equals x, and 9 times cosine 41 degrees is equal to 6.8. And those are our answers. And that sums up our Physics 1 math review for some of it, and tune in next week for the Physics 2 math review. Some of that might also be useful for Physics 1. I'm sure some of this stuff is also useful for Physics 2 if you need a refresher.
So much for tuning in and watching the solutions for this week. If you're interested in working with me or getting more resources from me, feel free to click the link in the bio so that you can learn more, including how to work with me as your tutor. And until next time, happy physicsing!